Hi guys, I'm Smitha. Welcome back to my channel where I talk about all things AI and machine learning related. In today's video, we are going to be looking at a basic machine learning project on forecasting. It's going to be extremely beginner friendly, so even if you don't have prior knowledge of ML and machine learning, you will definitely be able to follow along, and I'm going to go really in depth so that it's really easy for you guys to understand. Before we get started, if you are new to my channel, I'm Smitha and I post weekly content on machine learning and really in-depth machine learning tutorials, which take a lot of time and effort to make. So I really appreciate all the support that you guys give me. So if you're new, definitely hit subscribe if you're planning on learning machine learning. Without any further ado, let's get started. So for this project, we are going to be looking at a competition on Kaggle. It's called Store Item Demand Forecasting Challenge, and essentially what we are doing here is we're looking at the past 5 years of store item sales data, and based on this past 5 years of sales data of different items within 10 different stores, what we're going to be doing is we're going to be predicting the next 3 months of sales for each individual items in these 10 stores. So that sounds like a very complicated process, but I'm going to be breaking this down so it's very easy to understand. So let's go ahead and take a look at the type of data that we are going to be working with. So for this project, we have a tabular data, and the data that we have, there's 4 different columns within it. The first column is date. The second column is the store ID. The third column is item ID, referring to the ID of each item within the store. And the fourth column is the number of times it has been sold. So the fourth column essentially refers to the number of times this item has been sold at this store on this date. So this is entirely the data we have, and we have this data for lasting for the past 5 years. And based on this, we want to predict the next 3 months of sale for each individual item. So how do we go about doing that? In order to solve this problem, we are going to be making use of an algorithm called CatBoost. CatBoost is an algorithm for gradient boosting on decision trees. Now, you might not understand exactly what this is, and for this project, you don't need to understand exactly how CatBoost works because it's a pretty complex topic. But in the future, I will be making a video on gradient boosting as well as decision trees, so you can check that out when you're interested. But what you should know about CatBoost is that it's a very popular machine learning algorithm which is used in recommendation systems as well as forecasting. So this is perfect for our use case. The second Python library which we are going to be using is called Upgini. Upgini is going to help us to achieve a model with a very high accuracy rate when it comes to forecasting sales of these different products. So the thing with machine learning is, although the model is very important and we have chosen CatBoost as our model, data is also extremely important. So the data that we're using to train our CatBoost model is also extremely important. Currently, if you look at our data, it is very sparse. We only have 2 main features to look at, which is the date of sales as well as the number of sales. So this is not exactly a lot of information for our machine learning model to understand how it can use just these bare 2 different types of data in order to predict future sales. So this is where the Upgini library actually comes in. So the Upgini Python library automatically searches through thousands of different public data sources and helps us to find the most relevant features which work for our project. So for example, if you're thinking about predicting sales of different products, we would naturally have to think about how the economy is performing. In order to understand how the economy is performing, we would have to look at different economic indicators. And that would involve us having to find a completely different data set and integrating it with our current data set. And with the help of Upgini, we don't have to do any of that because that is automatically done for us. So I think this is an excellent use of the Upgini Python library. And I think this is a great use for a lot of different machine learning projects, which I'm sure you guys are going to be doing in the future. So let's go ahead and hop right into the code. You guys can use Jupyter Notebook or any other IDE you would like, or you can also use Google Colab, which is what I'm going to be using in this tutorial. It's the most easiest to use, so it's very beginner friendly. So if you guys have not used other sort of IDEs or Jupyter Notebook before, you can go ahead and use Google Colab instead, and it's much easier to follow along with. So let's get started. So the first thing we're going to do is install all the libraries that we need for this project, and that is Upgini, CatBoost, and Pandas. So let's run the first command. So we are going to be doing pip install Upgini and CatBoost. So go ahead and run that. So once we've downloaded these Python libraries, the next thing we're going to do is download the dataset from Kaggle or this GitHub link, which I'm going to be giving. Either one is fine. Once we have downloaded the dataset of the store sales, what we're going to do is we're going to split that into a training dataset and a testing dataset. So a training data set is one which we will train our model on. So we'll be providing both the input and output columns. Basically what we wanted to provide, we'll show all of that to the model. And with the testing data set, we're going to test how accurate the model is. So that's how it's going to work. Now, there's no standardized way of splitting a data set. Usually people apply the 80-20 rule, which is you split 80% into training and then you keep 20% for testing. But that's not always the case. There's so many factors involved, such as the size of your data, what type of data you're dealing with, etc. So our sales data is actually a type of time series data, since it's actually dependent on time. So the way that we split our data set into training and testing data set is definitely going to be slightly different. We can't just randomly use a percentage rule. We would have to look at the dates as well. So I'll explain how exactly we are going to be splitting this data set in a bit. But let's go ahead and download the dataset first. So we're going to do from OS path import exists, import pandas as PD. So pandas is a library that we're going to be importing because we want to deal with data frames. We're going to be downloading a CSV file and we're going to convert that into a pandas data frame, which is going to be much easier to work with, and we're going to push that into our model. So what this line of code does right here is if it's actually checking if we have already downloaded the file. So if we already have train.csv.zip, it's not going to download it. And this is important because if you're planning on rerunning these steps, it's important that you're checking if it already exists instead of like re-downloading the dataset every single time. So this is a good check to have. And right here in this line of code, what we're doing is we're reading the CSV file, and putting that into a data frame called df. So we're gonna go ahead and take a random sample of 19,000 data points from this data set, and then we're gonna actually do some data processing. We're gonna be changing the store and item columns into string. And we're also going to be converting the date column into a pandas date time column. This will make sorting, which we're going to be doing in the next step, much easier. And here we are going to be sorting. So since we have taken this like random sample of 19,000 data points from this pretty large data set, we are going to have to sort it by date again so that we get it in chronological order. And once you've done that, let's do df.head, which gives us the top 5 rows, the first 5 rows, and let's actually run this entire block of code in order to see. So here we have it. This is our data set, and we can look at the type of columns, which matches the data set that we downloaded from, and also the top 5, the first 5 columns of the data set as well. Next, we are going to be splitting our data set into a training set and a testing set. Since our data set is a time series data set, we are going to have to split it according to time. And our data set contains all of these like store sale values from the year 2013 till 2017. What we're going to do is we're going to put all of the data between 2013 till 2016 into the training data set. And the remaining year, 2017, is what we're going to be putting into the testing data set. So let's do that. We are going to be calling our training data set train equals to df So this essentially means by looking at the date column, anything which is before January 1st of 2017, put all of those rows into the train dataset. And for test, we are going to do the exact opposite. Perfect. So let's go ahead and run that. Next, let's also split our data sets, like train and test data sets, into features and labels. So features are our input values and labels are what we want to predict. So let's go ahead and do that. So our training features is every single column right here, except for sales, because sales is what we want to predict. So we're going to put that into train target. And we're going to do the exact same thing for test as well. Test.drop. And go ahead and run that. So the next step is arguably the most interesting part of this project, and that is we're going to actually enrich our features with the Upgini library. We are going to be getting brand new features which are relevant to our data set. As I mentioned earlier, having just 4 different types of data is not really that great when we want to predict future sales. So we're going to make use of Upgini and get brand new features which are actually relevant. So let's actually look at how we can do that. So from Upgini, we are going to import features enricher as well as search key. And from Upgini metadata, we are going to import CV type. So we're going to create a brand new features enricher with search key with search keys of date, and CV equals to CV equals to CV type dot time series. Okay, so what have we just done here? We have created a brand new features enricher and we have given it the search keys of date. So it's very important that we do that because we want data referring to these same date types, right? So whatever new data that Upgini is going to give us, we want it to be referring to the same type of dates that we have. So since our data set has data between 2013 and 2017, we want data which is specific to this time. We wouldn't want data from 2018 or even years before 2013 because that wouldn't be relevant. So it's important that we use date as a search key in this instance, and CV type dot time series is essentially telling the enricher that, hey, this is actually a time series data set. So that is also something to keep note of. And once we have defined our enricher, we are actually going to fit it to our data set, to our training data set. And earlier, how we have split our training dataset into features and target, we are going to feed that in. And we are also going to be giving it our evaluation dataset, which is our testing dataset. Once you hit run, this step should take about 2 to 3 minutes, as it takes some time to actually get all of the relevant features as well as something called a SHAP value. And I'm going to explain exactly what this is. Once the cell has finished running, you should get a table which looks something like this. In our case, we now have 24 relevant features. The first two we already had, right? So item and store, this data was already here, but all of this other brand new data has been generated by the Upgini library. It has went ahead and looked at hundreds and thousands of different data sets and found data which is relevant for our prediction. And we have something here called a SHAP value. And you guys must be thinking, what exactly is that? Well, in short, it's a mathematical value which indicates how relevant and or how influential this feature is towards the prediction. So as you can see, the first two features are item and store. And these are features that we already had in our data set, and they play the most important influence and most important role in our prediction. So item has the highest SHAP value, which means that it plays the most influence towards our prediction, and store has the second highest. In third place, we have weather, and we have week, different values of week and year, as well as in the sixth place, we have Dow Jones. So Dow Jones index, that's an economic indicator. And we also have the price of silver and different other financial economic indicators is what we have. And we also have the corresponding SHAP values. So we know how influential these new features that Upgini has found will be towards our prediction. So this is an extremely cool Python library which is very useful, especially if you don't have a lot of data or your data is very limited. You don't have a lot of features and you want to get good predictions, but you don't want to go and try to find brand new data sets and try to integrate it with your data set. So this Upgini Python library definitely helps with that. Another really important thing to note is that when it comes to the search keys that Upgini uses, you can actually provide multiple different search keys depending on your data set. For this dataset, we provided date as a search key, but you can also use email, IP address, phone numbers, and many other search keys as well, which enable you to find different datasets. So search keys are really important for the Upgini library, and you can use many different types of search keys in order to find the most relevant types of data for your dataset. In the next step, we're actually going to define our CatBoost model. So from CatBoost, import CatBoost regressor, and from CatBoost utils, import evaluation metric. So our model is equals to CatBoost regressor and we need to provide some input variables for this. Now that we have defined our CatBoost regressor model, what we're going to do is actually calculate some metrics before and after using the enrichment with our new features. So the Upgini library already has a calculate metrics model for enricher, and we're going to call that, and we're going to pass in train features, train target, which is our target value set we want to predict, evaluation set similar to the previous enricher, now we are giving an extra variable called estimator, and in this situation estimator is actually the model that we just defined, the cat boost regressor model that we just defined. So we are also defining a variable called scoring. Scoring is essentially how we're defining essentially how do we want to score how accurate this model is or not, and we're going to be making use of the mean absolute percentage error in order to do so. So go ahead and run this cell. Once our cell has finished running, you get a table which looks something like this. And the most important thing is comparing the baseline mean absolute error with the enriched error. So as you guys can see, when it comes to baseline, so that is without any of the new features with the Upgini that the Upgini library has given us, we get about 25% error rate. But if we include the new features with which we have gotten with the Upgini library, our error rate is significantly decreasing in both the trainings dataset as well as the testing dataset. So that is pretty good. So now let's actually go ahead and train our model. Now that we have seen these mean absolute percentage errors, we should actually go ahead and add all of these new features into our existing dataset. So let's do that. We're going to call our new training and testing dataset as enriched train features. So we can make use of the enricher.transform model, which is part of the Upgini library. We feed in our existing training dataset, which is train features, and we get a brand new enriched train features dataset, which includes all the new features that Upgini has created. And we're going to keep input equals to true so that our existing initial columns are remaining there. And we will be repeating this for the test dataset as well. Now go ahead and hit run. So now that we have created our enriched data set, what we're going to do is two things. The first thing we're going to do is we're going to train and evaluate our model on our original data set without all of these enriched features. And then we're going to do the same thing. We're going to train and evaluate our model with the enriched data set. And we're going to compare the error rate and see which one actually turns out better. So first let's do model fit. Model.fit, and we're gonna do it on our original dataset, which is train features. So here model.fit is essentially training our model on our train features and train target. And we are going to predict with test features. Once we've gotten the predictions, we are going to evaluate with test target dot values, predictions, and SMAP. And SMAP. And SMAP essentially stands for symmetric mean absolute percentage error, which is going to give us essentially a percentage error between our test target values, what it's actually supposed to be, and what our model actually predicted. So let's actually run this. So this is the error rate when we use our original data set without all the enriched features. Now let's repeat this with our enriched features dataset. And let's run this. So when we make use of our enriched features dataset, we get an error rate of 14.7% compared to 37.6% when we just use our basic dataset. So clearly it makes a lot more sense to use something like Upgini for this project, which allows us to create a lot of new features which are relevant to our dataset and to our use case in order to get a better model and a much better accuracy rate as well. So guys, this was a really basic machine learning project, and I hope you guys were able to follow along with this sales forecasting project. I'm sure it was pretty easy to follow along, and I went pretty in depth into a lot of different concepts such as CAD boost and feature enrichment with Upgini, etc. And we also looked at a bunch of different metrics like mean percentage squared error and many more. I hope this tutorial was really helpful, especially if you're starting out with machine learning. This is an excellent project to start out with. Let me know what you guys thought about this in the comment section below. Thank you guys for watching, and see you in my next video.